Today we're gonna look at renewable energy of fuel cell. For introduction, a fuel cell is an electrochemical device that converts the chemical energy of a fuel directly into electrical energy through a chemical reaction, rather than through combustion. Unlike batteries, fuel cells do not run out as long as fuel and an oxidizing agent are supplied continuously. So we're gonna look at basic operation of a fuel cell. Fuel, usually hydrogen, is continually supplied to the anode. Oxygen or air is supplied to the cathode, and at the anode, hydrogen splits into proton H+ and electron E-. Electron flow through an external circuit producing electric power, and proton pass through the electrolyte to the cathode, and power is generated as long as fuel and oxygen are supplied. For working principle, fuel cell work on the principle of electrochemical energy conversion. As we know, chemical energy go through electrical energy. It was direct conversion. Like we can see, the 2H2 plus O2 turn into 2H2O plus electricity plus heat. At the diagram, we can see how the working principle of the fuel cell.
So the construction of a fuel cell. This slide shows the construction of a fuel cell. The anode allows hydrogen to enter and react, while the cathode allows oxygen to react with protons and electrons. The electrolyte conducts ion but block electrons. The catalyst layer speed up the chemical reaction, and the bipolar plates collect and distribute current. So next, this slide explains the material used in fuel cells. Different fuel cells operate at different temperature. The anode and cathode need good electrical conductivity and stability, while the electrolyte must conduct ions efficiently. Suitable materials are important to improve the performance and durability of a fuel cell. And next is the requirements of a fuel cell. A fuel cell requires a continuous fuel supply and oxygen supply to operate. It also needs a suitable electrolyte, catalyst, temperature control, and water management system. Lastly, the system must prevent gas leakage and be connected to an electrical circuit to use the generated energy.
We're moving to example of actual site plus application. Fuel cells are widely used in real applications such as residential power system in Japan, hydrogen power buses in major cities, backup power for data centers, and spacecraft power system by NASA. These examples prove that fuel cells are reliable, efficient, and suitable for clean energy generation. We can see, or we can look at the first picture of NA from Japan, which use fuel cell. Also, we got fuel cell buses, such as those buses in German. And then we got data center backup power. And for the last one, we got Apollo 11 fuel cell. Next, we're moving to impact towards society of fuel cell technology. Fuel cell technology has a positive impact on society by improving public health, protecting the environment, maintaining high safety standard, and complying with legal regulation to support sustainable energy development. First, we got health. Fuel cell produce no harmful pollutants such as carbon monoxide, sulfur dioxide, or nitrogen dioxide during operation. Then, environmental. Fuel cell emit very low or zero greenhouse gases, especially when using hydrogen from renewable sources. Next, we got safety. Hydrogen is flammable, but fuel cell systems are designed with advanced safety feature. For the last impact, we got legal and regulatory impact. Fuel cell system must comply with electrical safety standard, environmental protection law, and hydrogen storage and transport regulation. Then, government support fuel cells through clean energy policies, green technology incentive, and carbon reduction targets.
Now, I would like to talk about the Sustainable Development Goals, specifically focusing on how we can bridge the gap between universal access to affordable and clean energy and the development of resilient industry, innovation, and infrastructure. By integrating this advancement, we can build more inclusive and sustainable cities and communities that are better equipped to handle the modern urban challenge, all while prioritizing the urgent climate action required to safeguard our environment for future generations. In conclusion, fuel cells are an efficient and clean energy technology that converts chemical energy directly into electricity with water as the main byproduct. They offer high efficiency, low emissions, and wide application potential, making them promising for sustainable energy future. That's all from us, and thank you very much.